Welcome back to Advent of Code 2019, day 22, part 2. I'm in the middle of day 22. This could be a short stream because I think I figured out roughly what to do for part 2. It involves a bit of maths. So yeah, as I suspected before, it is a kind of specialized. This is some kind of algebra, group algebra, permutations type thing. It's not too complicated, but it does require a bit of past knowledge on this topic. So if I open Paint, maybe we can try and figure this out. Damn it, I have to do the capture for this chat thing. Why are you always asking me in the middle of the stream? Let's see, motorcycles. Yep, that's a motorcycle. Yes, stairs. Oh my god, how many of these do I have to do? Traffic lights now? Okay, thank you. Oh my god. Alright, so. Open Paint, which I should have done before the stream, but... Okay, so we've got... Paint open. Okay. So, what we've got is a permutation, a shuffle of the deck. And we know we're able to work out where a given element goes. Okay. Which is good. But... So at this point, we don't care much about the nature of the permutation. We're just able to calculate where a given element goes. But that was my mistake, slightly. There is still some more information about the nature of this permutation, which matters here. Okay. So, if we think about it, if we have a... So we have a permutation, right? Which maps x to, like, p of x, right? And we're able to compute that for a given x. But we can't really do it many, many times. But if we look at all the individual operations of this shuffle, there are 3 types, right? So there's the reverse, that's the simple one. But that's almost like negative. Or it's like... So when you reverse the deck, you're kind of doing x to... It's like n minus x plus 1 or something like that. I don't know. Then there might be a plus 1, minus 1. Doesn't matter. If you do the cut, then it's almost as if you're just doing x plus the cut factor, right? Mod n. Everything's mod n. Even here, but in the reverse it doesn't matter. So it's like you're just adding something. And if you do the... what was the other one? the other one, then what was it called? Increment. No, yeah, increment. Then you're kind of multiplying. So if you do increment k, it's essentially k x mod n. All right. So if you look at these, they're all linear functions. So if you do any combination of these, any number of times, it all equates to some linear function x to a x plus b. Like, you could just compute the a's and the b's for every operation to get the final a and b, or we could just do it and find out what the a's and b's are afterwards, because now that we know x maps to ax plus b for some fixed values of a and b, we can just work out a and b. So if we set x to be 0, see where 0 maps to, then that'll immediately get us what b is, because the a is irrelevant. So we could do that. We're doing this for the inverse shuffle, and then for x equals 1, we could. All right, let's try and do that, and then we'll see if it works, so we can then test it. So instead of doing that whole shuffle, we would then be able to just do ax plus b to find out what the result of the shuffle is, instead of doing the shuffle. And so the input is no longer relevant, and we've got a very simple way to apply the function. Okay. So let's see. So here we don't need functools right now. Turn that on. So this is our inverse shuffle. What was K and I? Alright, this is inverse shuffle once. Okay, you know what? We don't need this thing. We can take that out. That was an attempt to do a multi shuffle. Doing a shuffle n times. Alright, so we know how to do one inverse shuffle. We want to find the A and B. So f, so let's just write a comment here. F of x equals ax plus b. Alright. Compute b. So we do so if we do inverse shuffle, okay, inverse shuffle of 0, would that just give us B then? Yeah, it will, won't it? It's doing. Alright, try that. Inverse shuffle. It's using the n. Okay, try that. B is that. Now what's A? Is that within... Yeah, it is. Okay, so now we want A. So we just want to do... So if we do inverse shuffle of 1, that would be A plus B. So then subtract B, that would be A, right? Okay, so we've got A and B. Now let's test this theory. So we do inverse shuffle of, let's pick some number. 67. And print A times 67 plus B mod. Well, you don't really need to do the mod, but we can do it. And they should be the same. But you do need to do the mod, sorry. Yes! Okay, we're getting somewhere. So that means now we never need to call this method again. We now know how to do this quickly. Alright, what now? So now we're trying to apply this inverse shuffle, which is now just AX plus B. And we're trying to do it this many times. Okay. So it's AX plus B. Let me bring the paint out again. So, if you apply the function once, it's going to be AX plus B. If you apply the function twice, it'll be... So you'd have to multiply out this, so you'd get A squared X plus AB plus B. I'm just looking at the pattern here. If you did it 3 times, you'd have to do A cubed X plus A squared B plus AB plus B. Okay, so the general case is A to the K X plus, and then you got B multiplied by, so it's going to be all the way from A to the 0 plus A to the 1 plus dot 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 plus A to the K minus 1. That's geometric progression. So that's 8. Can't remember. What was the formula for this? Is it a to the k minus 1 over a minus 1? I actually don't remember. I'm just going to look this up just to make sure I got it right. Sum of geometric series. So r to the 0 plus r to the 1 plus dot 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 plus r to the n minus 1 equals 1, says r to the n minus 1 over r minus 1. Yeah. And this is a. That's it. Okay, fine. So that is the final. Okay. X plus B. So that's constant time. Computable. Wait, no. To do exponentiation, we're gonna have to. But Python has a power method for the exponentiation, so I'm pretty sure it can just do it. So this is the formula. The only catch is doing a to the power of k for a big value of k. You need to use modular exponentiation, but Python has that built in, so you don't have to write it yourself. I think other languages you probably would. Okay. Just write that down. A to the k x plus b a to k minus 1 over a minus 1. But I mean, we're basically there now, aren't we? We're just applying 2020 with bx here, so. So once we've got that, so let's compute the BA bit. All right, so we got, just say temp equals but wait, when it's modular, how do you divide by a minus 1 here? Because that's not, you can't divide. Oh, I forget. So you have to find them. Find the modular inverse of a minus 1. Okay. N is a prime, so every element has the modular inverse. But I forget all this stuff. Is this where you use... Oh, you use Euler's theorem. when m is prime, it's just... Oh, we already did this earlier, didn't we? A to the m minus 2 mod s. So it's a to the n minus 2. Okay, so... So the modular... So... Modular inverse of a minus 1. That's what we want. Let's call it t, I don't know. T equals... So it's going to be a minus 1 to the n minus 2 mod n. Okay. That gets us that. So we want a. So we want power a to the power of 2020. So index. No, not index. To the power of num, which is that. Num. N. Minus 1. But it could become negative, so we've got to do this. And then times the inverse of a minus 1, so that's going to be t. Should we just do these as a series of steps, otherwise it's going to look horrible. So let's just, hang on, just do temp equals power of a to the num t minus 1% n. Okay, that's the first step. And then we do temp equals, so it's going to be temp times t, the modular inverse of a minus 1, % n. Okay. Then we multiply by b. Temp equals temp times b % n. And then finally we do temp equals, it's going to be temp plus power of a to the power num n. So that again, which we've computed once already, times index 2020 % n. Is that it? Print temp? So POW should just do this efficiently. Debug. Is that it? The result? It's easy to get this wrong if we've got the formula. Oh, that's it. So the key... I was pretty close last time. The key step that I missed, and I did look up a hint for this, just a very vague hint. The vague hint was that this permutation is linear. That was pretty much it. It clicked once I read that. But that is an important lesson. Always keep an eye out for linearity, because when something's linear, especially in these advent of code problems, that's usually a clue. Because linear, that's the goal of mathematics, isn't it? Make everything linear. We want everything to be linear. And if anything's non-linear, we try to make it linear. That's just like the one lesson I remember the most from university level mathematics. We want everything to be linear. But once it's linear, you don't even need to compute the coefficients. You just compute the permutation. You can get the coefficients from the result pretty easily. Modular inverse. Use Euler's theorem to get the modular inverse. That's something I didn't remember. I mean, it's still pretty specialized. That's going to be quite hard for anyone who's not studied group theory, permutation theory, combinatorics, just even number theory for the modular inverse and stuff like that, or cryptography. So people would get stuck and they wouldn't even know what to look up or what to learn more about in order to get to the answer. So I can imagine that would happen to some people, but it was okay. It was actually a pretty good problem. Specialized problem, but a pretty good one. I'll have to keep in mind. I don't think he'll put problems like that again, but maybe. So you can't really glean anything from these stats here. It's a bit tricky to... So yeah, fewer people comparatively compared to all these problems here. Relatively few people actually did part 2. You can see that. Okay. And for the next problem, the ratio is very high for solving part 2, so that indicates it's probably an easy problem. We can take a sneak peek now. I'm not going to do it now. Yeah, that was a nice refresher of group theory, which I didn't like. So I probably would have been able to solve this after my first year of undergraduate mathematics, but probably not using my high school level mathematics. I did actually do group theory in high school, but it's probably not solid enough to be able to... I wouldn't know how to do the modular inverse of... I probably would have got stuck as far as how to compute a to the k minus 1 over a minus 1, which is actually the easiest part, but I wouldn't really have known how to use Euler's method for that. But everything else, I probably would have... I knew about permutations and stuff, and the geometric sum of sequence. Yes, the number theory aspect I didn't study in school. Yeah, I mean, in group theory, in algebra, in mathematics, that would have been a warm-up question. It wouldn't have even been an exam question. It would be too simple for an exam question. This would be like, this is the kind of question to be a warm-up that just shows how out of date I am with all the stuff I studied, but yeah. Looks like Woza and First have done all the problems. Alright, so tomorrow, next days will be day 23. So what were the times? I'm curious about... I think the times will be pretty quick for this. Because once you know what you're doing... you can pretty quickly, if you're a pro at these problems, you can pretty quickly assume it's going to be linear, because they always are, if it's solvable. So then you can just churn out a solution pretty quickly if you knew that. It's just that formula that I wrote at the end. So I'm guessing the time is really quick, maybe like 10 to 20 minutes. What was it? 22. Hello, Olympus Tiger. Two hours. Is this the same problem? 2 hours. Yeah, it is. Wow, that's way longer than I thought it would take. Because once you've got the you did day 22 a couple of days ago. How did you find it? It's the longest to leaderboard. I'm pretty proud of it. Yeah, it's... But I'm actually surprised it took them so long, because even though it is actually a specialized problem and quite difficult in terms of the mathematics, once you've got the formula, which is a classic formula, it's like... I've seen this formula so many times before. I'd have thought more people than that would just type in the formula, because my code, I mean, this is my code just looks like this basically. Oh, 2015, not 2019. I'm doing 2019. I don't know what 2015 is. I can look that up in a second. But yeah, it seems like I guess you do have to first do the shuffle, which is probably the longest bit, but it's not too bad. Once you've done that. Oh, the wizard fight one, I remember that. Like an RPG game. Once you've written... So this is the hardest bit, the inverse shuffle. But it's not that hard to write. Once you've done that, then the rest is just playing this formula. So that's super quick. I'm still surprised it took them 2 hours. Interesting. How long did it take me? This is my second stream. The first stream, I've got the video stored somewhere. (2022) part 1, 1.5 hours. It took me 2 hours, and that's with a lot of waffling and talking and stuff. So actually, I would have been in the top 100, apparently. Okay. I'm guessing a lot of the people competing in that year didn't really know enough about algebra, because it is quite specialized. Okay. So yeah, part 1 was 12 minutes, so it took them another, like, 2 hours, basically, to do the part 2. Yeah, surprises me, but okay. The wizard fight one, so this was... 2015. Day 22. Oh yeah. Was this the one that I kind of solved by hand beforehand? Or... No. I think I had someone in chat trying to solve it by hand while I was coding it, and we sort of... I think he almost arrived at the answer by hand. And he isn't a coder or a mathematician or anything, he's just someone who plays a lot of RPG games, so he was using his experience of combat systems and stuff, which is quite cool. Yeah, that was a fun one. I use Dijkstra's, but there isn't a specific grid and ends with 4.5 mil items in queue. Oh, I don't really... So you're trying to find, what, the least amount of mana to win? Are there any choices, decisions you have to make, or is it just like... You hit, they hit, you hit, they hit? Oh, you do actually make choices of spells. Ah, so yeah. So you do need to have some sort of search. So you can't just... But do you do like binary search amongst the different amounts of manas then? Like for a given amount of mana... Or... So like, given a amount of mana M, you then do a search, breadth first search, whatever, to Dijkstra to search to find a path which will kill them, and then go higher or lower for that M. I can't really remember what I did for this. So yeah, you're trying to basically find any path which gets the enemy to 0 health. That's the goal. Yeah, that's my guess for what I did. I don't remember, but I assume I would have just given a fixed mana, used a search to see if there's any path which leads to 0 on the enemy's part, and Dijkstra would, or A-Star even, would help cut out a lot of branches. And then just like halve the mana or double it or whatever, just to do binary search on the starting manas. I assume that's what I did. Oh, no, it's not the starting mana that changes. It's the amount you spend. Ah. But you could actually just alter the starting mana, because it's like that would force the amount you spend. Okay, cool. I just started 2023, so my knowledge on algorithms is not that great. My first year finished also. So you finished 2015 and you've moved on to the latest one? I can't remember how different they were to 2015. Did he have any assembly code problems in this one? In 2015, his first one, I think he was only expecting like 30 to 50 people taking part. And when he launched it, it was just spreading like wildfire, and he was getting thousands of people playing, and he had to increase his servers to keep up with it. Like, he only ever thought he'd have like 20, 30 people participate. He's got a talk. I think he did a talk at Google or something. Yeah, you saw that? Yeah, it's a good talk. He came in my chat once. He was watching me, Eric was watching me solve, I think, the sand problem in, I think, 2022 maybe. Yeah. He every now and then he stops in Twitch streamers chats if they're doing problems, usually for the live ones. Okay, so should we take a sneak peek of the next problem that I might do tomorrow? 23. I hope this is an easy one. I just want it to be easy. Oh, it's gonna be an int code. I don't know what this is about. It looks like just... On first glance, it looks like just some basic simulation where you just run your simulation. I don't see much in the way of algorithms here. At least... And apparently part 2 had a very high success rate for this, so... Okay, looks like an easy one. I guess I'll try and do that tomorrow. Yeah, I think people have said 2019 was like the hardest year, because this is where he started putting in some specialized things. Specialized mathematics, and he stopped doing that for the later years, because it was kind of... I think in general people didn't like that because it was a bit too specialized. But... Alright. Alright. Well, thanks for stopping by, Olympus Tiger, and I might be back on tomorrow. If not tomorrow, then maybe the day after. Or probably a couple of hours earlier than I did today's session, if I can manage. Alright, see you next time. Bye-bye.